All right, we've seen how JavaScript interacts with the web using DOM APIs, and how strict mode really helps us write cleaner code. So now let's tackle one of the most confusing, but also one of the most powerful ideas in the entire language, the this keyword. It can feel like it has a mind of its own, right? But what if I told you its behavior isn't random at all? Okay, let's dive in and finally crack the code on this. Okay, this sentence right here, this is the golden rule. This is the key to everything. See, unlike a lot of other languages, the value of this isn't set in stone when you write the function. It's actually decided at the very last second, right when the function is called. We call this the call site. It's all about how and where a function is invoked, not where it was born. If you can get this one idea down, you are already halfway there. So that's the million-dollar question, isn't it? If everything depends on how the function is called, well, what are the different ways to call one? Turns out JavaScript has a really clear, predictable set of rules that tell us exactly what this is going to be, and we're about to walk through every single one of them. First up, let's get into the 4 default rules. These are the automatic behaviors you're going to see 99% of the time when you're out there coding. Let's lock these in. Rule number 1 is probably the one that makes the most sense right off the bat. When a function is called as a method on an object, you can just think of it as the function to the right of the dot. In that case, this is simply the object to the left of the dot, the object that owns the call. And check this out in action. Here, we're calling user.greet. Since greet is being called directly on the user object, this inside that function becomes the user object itself. So when it says this.name, it's really saying user.name, and boom, you get hello Sarah. The object before the dot is king. It's as simple as that. Okay, but what happens when a function isn't attached to an object? You know, when it's just a standalone call, like my function quote. Well, this is where things get a little weird, and it all comes down to whether or not you're using strict mode. Take a look at this comparison. On the left, in old-school non-strict mode, calling a function all by itself makes this default to the global window object. This is not great. It can lead to some really bizarre bugs. But on the right, strict mode cleans up this messy behavior. It sets this to undefined, which is much safer because it prevents you from accidentally modifying the global scope. This is exactly why we always want to be in strict mode. So what if we're not inside any function at all? What if we're just at the top level of our script? In that global context, this refers to the global environment. For any code that's running in a web browser, this is going to be the window object that we all know. And here is a super quick way to prove it. If you pop open your browser's console and type this equals window, you'll see true. Just remember, this can change depending on where your code is running. In a Node.js environment, for example, the GlobalThis behaves a little differently, so it's always good to know your environment. Now, our last default rule is an absolute lifesaver for anyone doing front-end development. When a function is used as an event handler, JavaScript does something super helpful. It sets this to be the actual DOM element that the event happened on. And this is why this rule is so awesome. When you click the button in this example, the function runs, and inside it, this is the button element. You don't have to go looking for it. JavaScript just hands it to you on a silver platter. This makes it incredibly easy to change its text, add a class, or do whatever you want right from inside the handler. Super convenient, right? Okay, so those are the default rules. They're the automatic behaviors. But what if we want to break those rules? What if we need to step in and tell JavaScript exactly what this should be? Well, the great news is we totally can. Let's see how we can take full control of the context. First up is the modern powerhouse, the arrow function. Now, here's the most important thing you need to know about them. Arrow functions do not have their own this. They completely ignore all the rules we just went over. Instead, they just inherit this from their parent scope. This is called lexical scoping, which is really just a fancy way of saying this is determined by where the function is physically written in the code, not how it's called. This makes them incredibly predictable. And that predictable nature solves a classic, very frustrating JavaScript problem. Look at this. We're passing the user.say method to timeout. But when timeout calls that function a second later, it's just calling it as a plain old function, totally disconnected from the user object. So in strict mode, this becomes undefined and our code breaks. The context is completely lost. But just watch this fix. It's so elegant. We wrap the logic in an arrow function. Now that arrow function doesn't get its own this value. It just looks one level up to the say method it lives inside. And inside say, this is correctly the user object. So the arrow function inherits that correct this, and our code works perfectly. Problem solved. Now, besides arrow functions, we have three classic methods for explicitly telling a function what this should be: call, apply, and bind. Think of call and apply as call now buttons. They run the function right away, but let you specify the context for that one single call. Bind is the different one. It doesn't call the function. Instead, it creates a brand new function with this permanently locked in place, all ready for you to use whenever you want. So, call and apply are almost identical, as you can see here. The only difference is how you pass arguments to the function you're calling. Call takes them one by one, separated by commas. Apply takes them all at once in a single array. That's literally it. A good way to remember is C for comma and A for array. This is super useful for something called function borrowing, when you want to use a method from one object on a totally different object. And this brings us right back to our set timeout problem from before. Bind is the perfect tool for this job. Look at what we're doing. We create a new function called sayHi by calling user.sayhi.bindUser. This new function now has its this context permanently locked to the user object. It can never be changed. So when setTimeout calls it later, the context can't be lost. It's totally secure. Okay, so the most important part is knowing when to use these different tools. Let's put everything together and look at that classic callback pitfall one last time, just to make sure the solutions are crystal clear. This is, without a doubt, the #1 source of this related bugs. You have a perfectly good method on an object, you pass it as a callback to something like setTimeout or an event listener, and then, boom, it breaks, because the this context just gets wiped out along the way. So how do you fix this every single time? You've got two fantastic, reliable options. First, the modern approach. Wrap the call in an arrow function, just like in solution 1. Because arrow functions inherit this, it's clean, it's easy to read, and it just works. Second, the classic approach. Use the .bind method. As you can see in solution 2, this creates a new function with the context permanently fixed. Both of these work perfectly. The one you choose often just comes down to your team's code style. And here we are, the ultimate cheat sheet. This table brings everything we've talked about into one clear view. You've got the global scope, functions in strict mode, object methods, event handlers, arrow functions, and explicit binding with call, apply, and bind. Seriously, take a screenshot of this, bookmark this part of the explainer. This is your go-to guide for figuring out this in any situation you encounter. And that's really all there is to it. That this keyword isn't random, it isn't magic, it just follows a very specific set of rules. Now that you understand those rules and you know that it all depends on how a function is called, you're no longer guessing, you are in control of the context. So, you've now mastered one of JavaScript's trickiest concepts. Understanding this is the key to understanding how JavaScript handles context, which is going to be super important as we move into our next topic. Next time, we'll dive headfirst into asynchronous JavaScript, exploring callbacks, promises, async await, and how JavaScript manages to do multiple things at once. I'll see you then.